Hello, everyone. I'm right here. Yeah, that's me. Believe it or not, I'm the speaker. And the reason I'm dressed like that is because my name is Guy. I'm from Israel. And today, in Israel, we celebrate a Jewish holiday called Purim. And in Purim, everybody wear costumes, like this one, for example. All the kids, my kids, went to school today with outfits. Here are my kids. Okay? So this is what you do today in Israel. And I want to share some of the spirit of the holiday with you. Now, my intention was to speak the whole presentation with this outfit. My wife said, no way. These are serious people. It's Europe, right? Don't do that. And I learned to always listen to my wife. So I'm going to put this off. Okay. Now we can start. The session is how to use parameters like a pro and boost performance. Okay? Not clowns and stuff like that. Thank you for coming. Again, my name is Guy. You already know a few things about me. I have 3 kids. I'm from Israel. I'm a SQL Server MVP. I've been working with SQL Server for the past almost 20 years, doing lots of stuff. And as a consultant, one of the things that I encounter a lot are performance issues. And I think that most of the times, performance issues, query performance, is related to parameters or not working with parameters correctly, the right way. Okay, and this is why I want to talk about this today. One more thing, except for consulting and blogging and speaking, etc., I also run a SQL Server Radio podcast alongside with Matan Jungman over here, my co-host. And we release podcasts once every 2 weeks. We talk about SQL Server and community and everything around it. So go check it out, SQLServerRadio.com. And let's move on. I would like to start with a story. Okay? The story goes like that. I received a phone call from a client at one evening. And the client said, we had a store procedure which ran for like 2 seconds each time, consistently. It was great. Everything was good. And just 30 minutes ago, it started to perform very bad, okay, like 15 seconds each time. Consistent, 15 seconds instead of just 2. Something happened, you got to help me out. And when I hear such a story, the first thing I ask the customer is, what do you ask the customer? What did you do? You did something, right? It was 2 seconds all the time, now it's 15 seconds. You did something. Did you change the store procedure? No. Did you load data into the table? Lots of data? No. Did you add an index, drop an index, change the scheme of the table? No, no, no. Come on. No, I didn't do anything. I went to the customer, to the client side, looked at it, and I understood what happened, fixed it. A minute later, everything was back to normal, 2 seconds. And I'm going to tell you in this session what happened there and how I fixed it. Okay? This story happened to me many times. Okay, with the same, well, maybe different client, different parameters, right? I want to talk about what parameterization is in SQL Server and why is it important. It's very important to understand it. There are some problems with parameters. Okay, sometimes it's a good thing, sometimes it's a bad thing. I'm going to talk about that as well. And how can we deal with it the right way? Okay, what's the best practices for dealing with parameters when you develop in SQL Server? All right? Oh, what's that? That's not my presentation. Honestly. I see it here. This is fine. Yeah, nothing. I didn't do anything. I promise you.
It looks like Boston.
You can all come here and watch this screen. This one is working. Or my laptop.
Can we lift that up and put it on the podium?
From all the people in the world, why me? I can wear the clown outfit in the meanwhile, if you like, again. I can try dancing. I don't know.
By the way, I had the same problem too, parameter sniffing.
Parameter sniffing. Yeah, I'm going to talk about that. Well, in the meanwhile, I'll try to continue without the presentation as much as I can. Okay. Right. So let's start talking about plan caching. Okay. SQL Server has a plan cache, which is a memory space to store execution plans. Now it's the okay. Now nothing is working. You restarted the whole room, right? All right. So whenever you issue a query to SQL Server, the query processor gets the query, and it does a few things. First, it needs to parse the query. It needs to verify that the syntax is OK. Okay? If you have a syntax error at this point, you got a syntax error message, and rewrite your query. If it's OK, it needs to verify that the objects, oh, excellent, thank you. It needs to verify that the objects, the tables that you reference in the query actually exist. Okay? If not, you're going to get an error about that. Then, when SQL Server verifies that the table exists, it needs to verify that you have permissions to select or whatever you want to do from the table. Only after that, SQL Server can start optimizing. Okay? And first, it reduces the query complexity. It tries to change the query to something more simple. And then the optimizer comes into play and start optimizing the query, preparing an execution plan as optimal as it can for your query, and only then it starts executing it. While as soon as the optimizer gets an execution plan, the execution plan goes into cache, the plan cache, and it stays there. And the idea is that next time another user issues the same exact query, we can take the execution plan for that query from cache and save all the time involved in doing all the stuff I mentioned before and just execute it right away. Okay? So this is why the plan cache is there to start with. Now let's go back to my presentation. It's OK, it's me. This time it's me. Good. So this is my case study. No, just a query to show you, OK, this is the parameter I'm talking about. This one can be a constant value. It can be 17, 63. It can be a parameter, OK, the @ sign and the name of the parameter. And I'm going to talk about a simple case study, simple use case to demonstrate what I want to show you. And this is it. OK, we have a customers table, and we have a country column, and I want to write a query that returns all the customers in a specific country. Let's say Denmark. I don't know why I chose Denmark. OK, so this is my case study. I'm going to use this one throughout the presentation. And let's go to the demo. OK, this is it. OK, this time in Israel, because my demo is based on Israel. But it's the same idea. Let's go to my database. OK. It returns 77 rows in this case. Let's look at the execution plan. We get an index seek on the customers table. I have an index on the country column, right? And I want to show you the estimated number of rows, which is 77. This is what the optimizer estimated to come back from the table. And the actual number of rows, in this case the same, which means the optimizer was right. It chose the right plan. And it chose an index seek because the table contains, in this case, 100K rows, and 77 is few enough rows to use index seek and key lookup on the table. Okay? So this is a simple case, simple query, simple execution plan. And now let's move on. Okay, so I talked about plan caching. Okay, and again, when we issue a query, the query processor has to go to the plan cache and check whether an execution plan for that specific query already exists. It uses a hash value. It calculates a hash value over the text of the query, and if the same exact hash value already exists in cache with an execution plan, it makes sure that it's the exact same text, of course, and then it reuses the plan right away, okay? But even if there is a plan in cache, it still has to verify that the plan is valid. What does it mean, a valid plan? Okay, the plan might not be valid because the schema has changed since the last time it was put there. Maybe someone added a column for the table. Maybe someone added an index or removed an index. Okay? Maybe the statistics which the plan was based upon are not up to date. Okay? There is an updated statistics, and the plan is not valid because of that. If the plan is not valid, SQL Server will throw away the plan and start all the process all over again, recompile the plan, generate a new execution plan, which might or might not be a better one or a different one, if at all. Okay? And only when it has an up-to-date execution plan, it will execute it, of course. Back to the demo. Okay, so I'm going to create a view, and this view, I'm going to use it a lot. I'm going to select from sysdm exacache plans. This view shows me all the execution plans currently in cache, all the entries in the plan cache, and I'm going to cross-apply to two functions. One returns the plan itself in XML, and one returns the text of the batch represented by the execution plan. I'm also going to join to sysdm exaquery stats in order to get the last execution time. Okay? And I'll show you my view. Just a simple select from that. This is what I have in cache on my laptop right now. Okay, we can see these are all store procedures. If we scroll down, we can see other types of plans. This one, the object type is proc. Yeah, now it's stuck. Nothing works today. Okay. We got ad hoc, we got prepared. I'm going to talk about a little bit later about the object types. And we can choose any one of these. I can click the XML and get the graphical execution plan, or not. Oh, it's still running, sorry. Okay, that's enough for you. Yeah, okay. So any plan in cache right now, we can look at the plan itself and see everything inside it. This is my view. Let's empty the plan cache. DBCC free pro cache empties the plan cache, and select from the view again. Okay, we still have a few things because there are internal stuff that SQL Server does all the time that gets into the plan cache, but we can see that now it's empty. Let's run our case study again, all the customers in Israel, and let's look again in the plan cache. I'm adding a text filter to just look at my query, okay? And this is how it looks like, okay? So I can see my query from the plan cache. I can see the plan itself, as we've seen it before, the index-seek operation. I can see that it has execution count of 1, okay, because I emptied the plan cache and executed only once since. It's an ad hoc plan, and it's happened again. Oh, boy. It's an ad hoc plan, which means it's not a procedure. It doesn't use parameters. That's what ad hoc means, okay? It's just a static query with ad hoc values, static values, and it generated the plan for that. And if I could show you, then I would show you that if I use the same exact query, but just making something different, that the value is different, even a single space or tab or enter, okay? It's a different text of the query. It's a different hash value. It's going to be a different plan, okay? So I'm going to show you, hopefully, in a while. And this is how the plan cache works. Whenever SQL Server recognizes the exact same hash value of the text, the exact same text, it reuses the plan from cache. Now, if you have, for example, our case study, if you have a query that selects the customer for a specific country and we use constant values, okay, this was IL. If I want, another user wants to run the same query but ask for customers from France, it will use FR. It's the same query, but since the text is different, SQL Server will optimize it from the start, from scratch, and generate a different plan. It will probably be the same plan, but it has another entry in the plan cache. And think about, again, this is a simple example, so we don't have so many queries. But think about another query that selects by customer ID, for example. Okay? And you have millions of customers. So for each customer ID, it's a different text, a different query, a different plan. A lot of CPU and memory resources are wasted just to compile the same query plan again and again and again. It's a real waste. So this is where parameters come into play. Okay? Instead of using constant values, we're going to use parameters. I'm going to use select from customers where country equals @country ID. Okay? And when I use parameters, SQL Server, it's the same text. The value of the parameter changes, but it's the same text of the query. It's the same template of the query. And SQL Server can reuse the plan again and again, even for different values. Okay? Again, I would show you if I can in a minute, I hope. Right. Let's move on. I'm going to show you later several ways in which you can execute a query with parameters, without parameters, static SQL or dynamic SQL. I want to show you how you run a query from within SQL Server, from Engine Studio, for example, and how you run a query from an application, from .NET application, how you run the same query from a store procedure. And there's a last option, how you run a query with not parameters, but local variables, which look the same, but are completely different. Okay? And this is something that I see people do a lot. It's a common mistake. Okay? People think that local variables behave the same as parameters, but they're not. Okay? I'm going to show you that as well. What else? I'm running the presentation in my mind. Okay, so I'll move on. I want to talk about parameter sniffing, which is a very important concept when you talk about parameters. The idea of parameter sniffing, let's think about a store procedure, okay, which is, I don't know if it's the most common use case for developers, but let's assume it is. When you use a store procedure with parameters, the first time the SQL Server is going to execute the store procedure, there is still no plan for that procedure, of course. It will generate a plan for the store procedure. But while it generates the plan, while the optimizer tries to optimize the store procedure, the queries inside the store procedure, it sees the parameter values in that first execution. Okay? The user that first executes the store procedure executes it with, let's say, country IL. Restart again. Right. You hear me? Oh, you hear me. Okay. So the optimizer knows that the parameter value in compile time, while creating the execution plan, it knows that the value is IL. Okay? And it uses that value to estimate, using statistics, the number of rows to be returned from the table. Okay? So it knows that it's IL. And it estimates correctly, hopefully, generates a plan for that store procedure that is based on the IL value, puts the execution plan in cache for later reuse. Now, let's think about it. The next user comes along and executes the same store procedure with a different parameter. But now there is already a plan in cache. No need to generate another plan. So SQL Server will reuse, will reuse the plan from cache, which happens to be based on the IL value, parameter value. But now the execution is with, let's say, FR or US. Okay? And if the same plan for IL and FR, if the plan is good for both values, then you're good. But if there is another plan which would be better for FR, then you're stuck with a plan in cache which was based on another value. So sometimes parameter sniffing is a good thing, but sometimes it's bad for you. Okay? And I want to show you that, because now I can. Let's just get back to this demo. Execution count 1. If I run the same exact query again, and I look at the plan cache, we got execution count 2. Okay, so we see that there was a reuse of the plan. SQL Server recognized the same text. It reused the plan from cache. No need to recompile again. And I'm going to run the query again. This time, I just put a space in here, okay, just to show you that it really depends on the text itself. And now we see there's another entry with execution count 1. It's the exact same execution plan, but it's a different entry in cache. Okay? It went through the whole process of optimization. Right? Now, of course, if I use a different value like FR, so we get another plan in cache, and you get the idea. Okay? So much for this demo. Okay, you know that song? I love Paul Simon. Actually, I'm going to a concert by Paul Simon in Berlin next week, so I'm very excited about it. Is it working? No, what would I expect? No audio? I prepared a song. Never mind, never mind. I love this song. Paul Simon sings about 50 ways to leave your lover, and I say there are 7 ways to execute your query. Okay? That was the point of this slide. It didn't work. Let me show you. 7 ways, okay. It's the same view again. I already have it. Let's empty the blank cache. Okay, so number 1, I call it non-parameterized T-SQL query. Yeah. It's what we've seen before, and we can see that this is an ad hoc query without parameters. If we use FR, we get 2 different plans, although it's the same query. Okay? Number 2, non-parameterized dynamic SQL query. What I do here, I have a variable named country with IL, and I concatenate the value of the variable to the query itself. I build the statement dynamically, okay? But this is still non-parameterized query. There is no parameter here. It might look like, okay, but I just put the string here as a constant value, and I get the exact static query as before. Let's run this one. Okay, and we get another one. Now, I expect a question here. Nobody? You should have asked me, why, if this is the exact same query, after building it dynamically, it's the exact same query as the query before. Why didn't it reuse the query? Okay, it's the same text, it's IL. There's already a plan in cache for that query. And the reason is just the white spaces, as you can see here. Okay, it has another tab. If I build dynamically this query with the exact white spaces as the query, the static query I ran before, it will reuse the plan in cache. Okay, there's no difference. And of course, if I build dynamically another query with FR, this is the only change, then we will get a 4th execution plan in cache. Not good. So let's move on to parameterized dynamic SQL query. Here, I still want to build the statement dynamically, but I'm going to use parameters. Okay? So I have the exact same variable country, but now look at this. Inside the statement, I don't just concatenate the value. I use an internal parameter. I called it @pcountry, okay, to make a difference. And this is a parameter of the dynamic batch. And when I execute this batch right now, I'm going to execute it with sp execute SQL. I'm going to transfer the statement itself. I'm going to transfer a params variable, or params parameter, actually, that looks like that. It's the definition of all the parameters inside the dynamic statement with their data type, and then the parameters themselves. Okay, so pcountry, which is an internal parameter of the dynamic batch, will going to get a value of my local variable, which in this case is IL, and the dynamic batch will run with the parameter this time, not just a constant value. Let's execute it and look in cache. So now we have a new thing. This is a prepared statement, a prepared execution plan. Prepared means, it's not a very good word, it means it uses parameters. It's a parameterized query, okay? And we can look even at the text of the query. It looks like that. SQL Server puts the definition of the parameters within this prepared statement at the beginning, okay, pcountry as and char2, and then the statement itself. And of course, the statement itself does not include the static value, but just the parameter, okay? So we have a template, and we can reuse the same prepared statement or the same execution plan again and again with different values like this one. I'm going to use FR now, and hopefully, we're going to get a reuse. Let's look at the plan now, the plan cache, and we see, finally, a reuse of the plan. Okay, so now we can run this query again and again with different country values, and we'll reuse the same plan again and again. This is good. Let's move on. Let's see how does it work from the client side, from a .NET application, for example. So you have here a .NET application. Let me run it. Okay, here it is. I'm going to start with IL, and I have two options. I can run from .NET as a non-parameterized query or as a parameterized query. Let's start with a non-parameterized one. It was executed. Let's look at the plain cache. Sorry. Where am I? Okay. Here it is. It's the last one. It's an ad hoc, just like from SQL Server. I want to show you the code. The code for the non-parameterized query. Thank you. Here it is. Select. And again, I just concatenate the value from the text box in the form, okay? And it's a constant value. I send the query to SQL Server with constant value, just like we did with the execute statement, okay? With the non-parameterized dynamic SQL query. It's the same thing. But I have another option here, the parameterized query, which is here. Okay, this time I send SQL Server the template with the placeholder for the parameter, and I pass a parameter of size 2, data type nchar. The value comes from the text box, okay? And the direction of a parameter is it's an input parameter. And I now execute the statement with the parameter inside. So if we go back to the application, parameterized query, I want to show you how it looks like in cache. Okay, here it is, prepared. So once again, if I go here and change the value to something else, run it again, we get execution count of 2. If I use fr with a non-parameterized method, we will get another plan. Okay, I hope you believe me on that one. Okay, the next one is, of course, where it is, stop procedure. This is classic. Okay, we have a stop procedure with a parameter, a definition of parameter country, and the query inside. Let's create it. Not again. It's different this time. It's just blank. Okay. Don't touch it. Don't move. Don't breathe. Don't laugh, please. No. Okay. Let's execute it first with IL. Okay. And look at the plain cache. Now we see a proc. Okay, so we got a third object type. We have an ad hoc query, a prepared statement, and a procedure. And of course, yeah, I know. Please come back. Okay, if we run it with fr, then in the plain cache, we get a reuse of the procedure. Okay, it's the same text, it's the same object, same procedure. Of course, we're going to get a reuse. That's the whole idea. Now, the seventh way to execute your query is what I call looks like parameterized T-SQL query. Here I define a local variable called country. I assign it the value IL, and I use it in the query. Okay? And now, if we look at the plain cache, first of all, it's an ad hoc. It's not prepared. It means there's no parameter involved here. Although it looks like, if we just look at this query, without the parameter, the local variable definition, it looks exactly the same as the query inside the store procedure. And the reason is that we use the same sign, the @ sign, for parameters and local variables. But it's a completely different thing. Okay? Let me prove it to you. If we go back to the query itself, let's run it again, and ask for the actual execution plan. Now look what happened. The estimated number of rows now is 5555, while the actual, we already know it's 77. Okay? So till this time, all the queries we ran, the optimizer was right about the estimation. This is the first time that we have a big mistake. This is a big mistake. Okay? And for that reason, the plan is also different. We have a clustered index scan instead of the optimal index seek we had before. Okay? This is not good. And the reason is we use local variables, and I'm going to show you in a few minutes why. What did happen? Okay? But this is not a parameter. Okay? Back to my presentation. Say bye to Paul Simon. Okay, I talked about parameter sniffing. Let's move on. Okay, it's the process of looking at the parameter values in the first execution. Okay, and the idea here to remember is that it happens at compile time. The optimizer acts at compile time. Okay? This is before we execute the query. And at compile time, thanks to parameter sniffing, the optimizer can sniff the values of the parameters and generate a plan based on these values. Okay? Now let's talk about the local variables we saw before. Local variables are not parameters. The assignment of value, okay, we had declare country equals IL. The equals IL part, this is the assignment of a value to the local variable. This part happens at runtime. Okay? So at compile time, the optimizer still doesn't know, it doesn't have a clue about the value of the local variable. And now when the optimizer has to generate a plan for the query, and it says where country equals add country, it has no idea about the value of add country. Okay? It has to do something in order to estimate the number of rows. And what it does, it uses general statistics on the table and estimates the average value, average number of rows per value in the table, okay, without taking into consideration the specific value in this execution. And in our case, the average value was 5,000 and something, okay, which is very wrong, okay, in this specific case. So, is parameter sniffing a good thing or a bad thing? In some cases, it will save a lot of compilations, okay, and we'll get the same optimal plan for many cases. But in some cases, we are stuck with the plan that is good for one case but not good for other cases. Okay? So let's talk about the cases where parameter sniffing is not a good thing and how we deal with it. Okay? One of those cases is non-uniform distribution. And this is our case study. Okay? I prepared the table, the customers table, with we have, if I remember correctly, we have 40% of the table from US, we have 30% from China, 30%, no, it's too much, 20%, 29%, I think, yeah, from UK, and 1% for all other countries, something like that, okay, just to generate non-uniform distribution. Let's look at it. This is right here. Empty the cache. And I want to look at the statistics itself. DBC show statistics will show us the histogram, the distribution of values within a specific index or column or statistics object. In this case, our index on the country column. Yep. And come on. You can see the histogram right here. Okay, and you can see the value, and you can see the equality rows. Okay, so you can see, for example, for China, CN, we have 30,000 and something rows, and for all other countries, we have around 70 or 80, something like that. We also have UK and US. You can see the idea. Now, this is a very simple case that I generated for the sake of this demonstration, but it helps me demonstrate the idea. In reality, you have many, many more unique values, and the histogram is much more complex. In some cases, SQL Server can't even generate a good enough statistics to estimate the number of rows for each case. Okay, this is a very, very simple case. Just for a second demonstration. One more thing here, you can see this value, the old density. This value, if you multiply it by the number of rows, in our case, you can see under the rows 100K, okay, you get the exact 5555 number we saw before. This is the average statistics, the average number of rows per unique value in the table. This is where SQL Server took the value from when it had the case of a local variable with an unknown value, because it happens only at runtime. Okay? It comes from here. Let's move on. Now, let's go back to our stop procedure. Okay? And first, run it with IL, and we get the index seek. Okay? We get 77 rows. This is the estimation, which is good. Now, the second time, I'm going to run it with US. We already have a plan in cache, and we're stuck with a plan that does an index seek. But this time, the estimated number of rows is 77 because it comes from the cache. The optimizer didn't have him go through the process of estimating again. Okay, he just took the plan from cache, and the plan from cache says 77. The plan was based on 77, but the actual number of rows in this specific execution, sorry, not this one. Anyway, 40,000, okay, something like that, right? It's a big difference. And the correct plan here was a clustered index scan, but we're stuck with an index seek, and we get bad performance, poor performance from this specific query for this specific value. Okay? So this time, parameter sniffing doesn't work for us. How do we solve this problem? A few options. First, we can issue the SP recompile system store procedure, which marks the plan as invalid. We talked about it before. This is one of the options to mark a plan in cache as invalid. The next time a user will execute the same store procedure, it will recognize that the plan is not valid, throw it away, and recompile it once again with a new parameter value. It will use parameter sniffing again and generate the best plan for that specific execution. So let's run it and execute it again with US. And since there is no valid plan in cache, we generate a new one. And this time, we get a clustered index scan. And the estimated value, okay, is 40,000, just like the actual value. Okay? But now, of course, if we run it with IL again, we have the problem in the opposite direction. Okay? Now we're stuck with the scan plan, and it's not right for the IL parameter value. So using SP recompile is like free will in the casino. You know, you get another chance. If it works, fine. If not, it's just a matter of luck. As hard as it sounds, it's just a matter of luck. The first execution determines the query plan that you get stuck with. If you, if not you, if the first user that executes the store procedure after a restart or after some reason that the plan became invalid, the first user will execute it with a parameter value that will determine the plan that you are going to be stuck with till the next time a recompile has to occur. And if that parameter value happens to be common or good enough for most values, you're fine. But if not, you're doomed. You're going to be stuck with a poor plan for most of your queries. Okay? So this is not a very good solution using SP recompile, but it might help you in some cases because it's very easy to do. Right? Now, another option is to add with recompile to the store procedure itself, inside the store procedure. What this does, it instructs the optimizer to generate a plan each time, in each execution. So now I'm going to execute it with IL. I'm going to get an index seek. I'm going to execute it again with US. I'm going to get a scan. Each execution gets its own plan. The optimizer does the process again and again each time. So it could be a great solution because you get the best optimal plan for each execution. This is excellent. The drawback here is that you're going to use a lot of resources, CPU and memory resources from your server, and it might be a very bad thing. It depends. If this store procedure is executed many, many times and it's quite complex, okay, you're going to pay for it in terms of resources, and it might not be good for you. But if this store procedure runs just once in a while, why do you care? Okay? Let him recompile it again each time and get the best plan for each execution. Okay? So it really depends. In some cases, this could be a very good solution and very simple, of course, to implement. Another option, instead of with recompile at the store procedure level, we can use option recompile at the query level. This is a query hint, a query option. I can put in a specific query hint saying recompile. Now, this is a simple store procedure with only one statement. Think about a store procedure with 20 or 30 statements, and your problem is only with the 17th statement. You can put recompile only there, and it will happen at runtime. So you don't have to recompile everything again and again. Okay? You have a planning cache for the store procedure. You reuse it, but at runtime, when it gets the specific query that causes you problems, it's going to recompile it at runtime, generates the plan for that specific execution using the parameters and values in that execution and move on. Okay? So this might be a better idea than just using recompile at the store procedure level. Another important thing about option recompile, because it happens at runtime, SQL Server sees all the values, the environment values, the local variable values. We talked about it before because it's at runtime. Okay? So for example, if you use local variables and use option recompile, you solve the problem of not knowing the local variable value at compile time because it happens at runtime. The compilation happens at runtime. Okay? This is important to remember. Let's just look at this. Okay, so again, IL, we get index seek. And guess what? For US, we get clustered index scan. Great. But again, we're recompiling again and again. It might not be good for you if it happens a lot in terms of resources. Okay? Let's try another thing. We can try another option, query option, called optimize for. This time, we instruct the optimizer to always optimize the query based on the parameter value US. Okay? So what I'm saying to the optimizer, ignore the value, okay? Ignore parameter sniffing. Ignore the actual value in this execution. think that it was US, generate a plan based on US. Of course, the results must be based on what the user asked for, okay? You're not going to get the results based on US, but the plan is going to be based on US. Because what I'm saying is, most of the people, most of the times, people ask for US, okay? So I prefer not to leave it to luck, okay? I don't want the casino effect. I don't want it, okay? I prefer to instruct SQL servers to use US always, and it will be good for most of the cases, and I'm willing to pay the price for those users that ask for, let's say, IL. Yes, they will have to wait, okay? At least I have more control of the process and not just leave it to the matter of luck, okay? So if I instruct the optimizer to use US, but I'm going to use, for the first execution, I'm going to use IL. Oh, sorry, didn't show you the plan, okay? I'm going to get a clustered index scan, although this is the first time the procedure is compiled, and I ask for IL, I get a plan that belongs to US. Of course, the results, I get here 77 rows. These are the Israeli customers. Don't worry about it, okay? The results are fine, but the plan is based on US. And I want to show you another thing. If we go to the select operator and go to the properties, we have the parameter list right here. And we can see all the parameters in this specific query. We have only the country this time. And we can look at the compiled value and the runtime value. No, we can't. Oh, boy. Now we can. Okay, so you can see that the compiled value is US, because this is what the optimizer based the compilation upon, and the runtime value, in this case, is IL. Okay? This is the place where you will look, even if regular cases, when you get poor performance for a plan, because the plan was based on some value in the first execution, and now it's a different value, you can go here and see the value that the plan is based upon versus the value that it is using now at runtime. Okay? Now, the last solution is the most complex one, but gives the best solution. The idea here is like that. I'm going to create a table, and the scheme of the table is going to be like the histogram of the statistics, because I want to take the statistics, a snapshot from the statistics, into my own table. And I'm going to use it to do it by using this statement. Insert into my table, execute dbcc show statistics with histogram. I get only the histogram as a record set, and I can put the values, the results from the histogram, into my own table. Let me show you the table. Okay? So now I own the histogram. I can do what I want with it. And I need to do some kind of manipulation now to distinguish between values. In this case, I want to distinguish between common countries and uncommon countries. Because for the common countries, countries which have a lot of customers, I want to have a plan that has clustered index scan. And for countries with only a few customers, I want to have a different plan, which is index seek. I want to have control. So this is, again, a very simple manipulation. What I do here is just delete all the countries that have less than 1% of the table, of the rows in the table. Okay, in our case, it's 100K, less than 1,000 rows. Okay, and it leaves us with China, UK, and US, okay, the common countries in my case. And I know this is a very simple case. In your production systems, it's much more complex, okay? We need to tweak this a little further. You need to play with it. There's a lot of fine-tuning to this algorithm. But I did this with several clients, and it works well once you get around it, and you get to know your table and the distribution of values inside the table. You can try and get to distinguish between the common values and the uncommon values. And once you have that, what I'm going to do now, I'm going to create a new procedure and add the suffix common. All it does is to run the query just as before, and another stop procedure with the suffix uncommon. They are identical with the same query. And now I'm going to change the original procedure, the one that the application calls, okay? And now it's going to be just some kind of a dispatcher. This stop procedure is going to check if the value that passed from the application, the country, exists in my common countries table, okay? The China, UK, or US in our case. then execute the stop procedure with common. Otherwise, if it's not a common country, execute the other stop procedure. That's all I do. And the thing that happens here is the first time the external stop procedure will be executed, let's say with IL, I will check and see that it is an uncommon country. I will execute the stop procedure with the uncommon suffix for the first time. Thanks to parameter sniffing inside the uncommon stop procedure, the optimizer will generate a plan with an index seek and put it in cache. I can reuse the same query, the same stop procedure again and again with uncommon values. The first time that a user executes the external stop procedure with US, for example, the external stop procedure will determine that US is a common country and will execute for the first time the common stop procedure. And again, thanks to parameter sniffing, the common stop procedure will generate a plan with clustered index scan and put it in cache. So we get the best of all worlds. We get only a single compilation, for each type, only 2 compilations, and we get a reuse of each group of values again and again. Okay, so we get an optimal solution. Let's see how it works. Okay, start with IL. Now we have, you got used to it, right? We have the first query here. I mean, come on, come back. No? That's it? Okay, thank you very much. No, I'm kidding. I'm not done yet. Anything? You've given up, right? So it's working, believe me. Okay? Yes, we have a question. Thank you. We have a question. Yeah. No, it's me. I'm looking. It's my eyes. Sorry.
If you would run this query for every country at startup, basically, you could basically force the system to make a query per country.
To make a plan per country? But this wouldn't be wise because, again, country, you don't have many unique values. But if you have like customer ID, you don't want to plan for each customer ID. The whole idea is to reuse the same query plan for a group of values that will benefit from the same plan. And it might be 1,000 or 1,000,000 values. Okay? You want a single plan for each group of values, not for each unique value.
So you don't want a single plan for each country?
No, because Israel and France, for example, as you've seen before, both has around 80 rows. Both will benefit from an index seek plan. I want to be able to reuse the same plan which has an index seek. There's no need to compile another plan which does the same thing.
Okay, but if you start up the system and you let it compile just all the plans for all the countries, then you're ready for the rest.
Oh, okay, that's an option. Okay, when we start first thing in the morning, okay, before people comes in, okay, we can generate a plan for each country, put it in cache, and start using it. Okay. Again, it might be a good idea for if you have just 20 values, no problem. But if you have 1,000,000 values, you don't want to have 1,000,000 plans in cache. You probably don't have space in memory for that. Okay. Right, we can continue, great. Okay, so the first query here is the statement that checks whether it's a common or uncommon, okay? It doesn't have a meaningful overhead. It's really a very, very simple and fast query. And the second query uses an index seek, which is what we wanted, okay? And if we run with US, we get a clustered index scan. We got a clustered index scan. And again, it happens only once, and we then reuse the same plan in cache again and again for each group of values. Okay. I'm not excited about it. I'm used to it. Okay. You with me, right? Great. So just to sum it up, we have the sys sp recompile to just get another free wheel in the casino and see what happens. We got a reader compile at stop procedure level, which will recompile the plan, the procedure again and again each execution. We got an option recompiler, the statement, the query level, which happens at runtime. We can use option optimize for to instruct the optimizer to use a specific value and effectively disable parameter sniffing. And we can use the last solution I showed you with multiple stop procedure. A question? Yes, please.
An alternative solution could be to choose declare a variable locally in scope of stored procedure and save the country to this one. Like declare a local country as
okay.
and then copy that to the dummy variable.
If you have a local variable in the store procedure,
To simulate the recompile option, because you said that if you declare local variable, that you use that inside the store procedure.
yes.
So you copy the parameter to the variable inside the store procedure. Would it have the same effect as recompile?
If you copy the parameter into a local variable, then it will have the problem I showed before. At compile time, when the optimizer generates a plan for the store procedure, it doesn't know the value of the local variable. So the query, which uses now a local variable and not a parameter, will suffer from a plan that has nothing to do with the value. It will be just an average value. It might be just, by luck, a good plan, but in most cases, it will not be a good plan.
So it's like recompile, can we say that, or it's the...
If you add option recompile, you solve the problem. Okay? But you solve it just the same with a parameter or a local variable. It doesn't matter. Okay? Yes, please.
What do you say about option optimize for unknown?
Yes, okay, thank you. You can also use option optimize for, not a specific value, optimize for unknown. Optimize for unknown means disable parameter sniffing. Okay, don't look at the parameter value, and just generate a plan based on an unknown value, just like the local variable case. Okay, and it sounds like a bad thing. Why would I want to disable parameter sniffing? It want to help me, but again, parameter sniffing might be a bad thing in some cases, and if it's bad, it's a matter of luck, okay? But you can play with it, and you can say, okay, in this case, I prefer the optimizer to ignore the parameter value and just use the average statistics. It might be a better choice than just using a specific value, which is not ideal. It's not common, okay? Thank you for this comment. Okay. Next, another common mistake. We talked about local variables. Another common mistake is to change the parameter value inside the store procedure. I don't have much time. I'll skip the demo. Okay, and the idea here is you get a parameter into the store procedure, and inside the store procedure, you change it. Okay, let's say you have a default value of null, and you say, okay, if it's null, then I want to change it to, let's say, last week. Okay, it's a daytime value. The default value has to be last week. The application transferred a null value, and I will change it if the parameter equals null. Let's change it to last week, something like that. And then you run the query with the parameter after the change. The problem here is, again, based on parameter sniffing. At compile time, the optimizer will use the parameter as it was transferred to the store procedure, okay? But not the actual parameter value after the change, because that happens at runtime. And then you're going to get a plan based on the parameter with which the application called the store procedure, which in our case is null. You get a plan based on null. But the actual plan has to be something else, completely different, and you get poor performance again. Okay? So if you change the parameter value inside the store procedure, or if you copy the parameter into a local variable, these are two common mistakes that I see a lot that cause poor performance, and you have to deal with it by either using option recompile and instruct the optimizer to recompile at runtime using the actual values at runtime, or you can send the last value after all the calculations, take the value you changed, and send it to another store procedure. Okay, and then you're going to have parameter sniffing in the other store procedure with the right value, and you're going to get a good plan there. Okay, that's another option. Right, last thing, simple versus forced parameterization. In SQL Server, we have two modes. Okay, this is a database property. At the database level, we can specify whether we want to work with simple parameterization, which means SQL Server will attempt to parameterize, to replace literals, constant values, with parameters, even if you didn't ask it to, okay? And it will do it under the simple parameterization mode. It will do it only when it is certain that this is good for you, that it doesn't matter what the value is going to be, okay? The plan is going to be the same. So you better use a parameter there, okay? And there is also an option to use forced parameterization, which means that for every single query, SQL Server will attempt to replace literal values, constant values, with parameters. And this might be a good thing in some cases, but it might not. Okay? Let me show you a demo, a quick demo. Okay. So again, empty the plan cache. The same query. We already saw it before. It is ad hoc, no parameters here, right? Because I used IL, a constant value. But look at this query. This time, I search by the ID, okay? Where ID equals 1, 2, 3, 4. Again, this is a constant value, no parameters here. But if we look at the plan cache, we get a prepared statement. We get a parameter. SQL Server by itself decided that if we replace the 1, 2, 3, 4 value with the parameter, it called it at1, and it determined that it's small int data type, okay? And it did it because it said, you're an idiot. I mean, me, okay? You should have used the parameter here, because ID, customer ID is a primary key. And no matter what value you put there, you'll always get a single row, and the plan will always be a clustered index seek, okay? So why do you do it? Okay, now you're going to use the same query with different customer IDs. You're going to get a compilation again and again and again. I'm going to do it for you. I'm going to replace it with a parameter, and I'm going to save a lot of resources from the server. Okay, this is a great thing. This is simple parameterization. Of course, if I use the same query now with 2, 3, 4, 5, I'm not even aware of what happens behind the scenes. SQL Server does it for me. It reuses the plan. Okay, this is great. Yes, please. No, there are many cases. Primary key is a classic case, but there are many cases where SQL Server will do it. Generally speaking, SQL Server will parameterize your queries when the plan is trivial. Yeah. You can look at the property of the select operator in the plan, and you can look at the optimization level property. It says trivial or full. Trivial plans are very simple cases of optimizations where SQL Server says it doesn't matter what you put here, this is the plan, okay? Generally speaking, and it will parameterize those queries. Only trivial plans. There are all kinds of cases for trivial plans. Primary keys is one of those. Yeah. Okay. My voice is back. Okay, let's just talk about what forced parameterization is and when it's good or bad. In some cases, I go to a client. The client says we have performance issues. I look at the plan cache. I see a lot of ad hoc queries, not using parameters at all. And my response is, you're not using parameters. You should rewrite your queries in the application to use parameters. This is going to save you a lot of space and recompilation because this is your problem. Once you do that, you're not going to suffer from CPU memory issues anymore, okay? And you get better performance. And then the client says, no way. I get it a lot. You don't touch the application. You're the DBA, you do your magic in the server and fix it somehow, okay? And that leaves me with trying to force parameterization at the server side, okay? So this is what we can do with forced parameterization. Now it's risky, okay? You should try it in a test environment and play with it and see what happens because it might improve some queries, but it might make it worse for some queries. And this is why you can do it not only at the database level as a database property for everything that happens within the database, you can also do it at the query template level. I'm not going to show it because I think it's too late. I want to summarize everything. But you can use, again, I'm going to upload, of course, the presentation, the demos. You get a full demo how to do it. You can use a plan guide to take a template from a query and generate a plan guide actually adds a query option to a query. And the query option is going to be parameterization forced. And this means that for that specific query, each time that SQL Server will recognize this query template, it will add the parameterization forced query option and force that specific query. So you can do it query by query. It's more complicated. It's more complex. It requires more maintenance, okay? But you have more control of what you do and not just the old database, okay? So this is what you can do with forced parameterization. So again, we can do it database level or the query template level. And let's summarize. Okay, so parameterization, again, is a very important concept. And if you don't handle it properly, you're going to suffer. And again, from my experience, many cases for poor performance are caused by improper handling of parameters, okay, one way or another. And we saw a few examples here today. So tip one, if you have a non-uniform if you have a uniform distribution, you want to use parameter sniffing, you want to use parameters, but if you have a non-uniform distribution, you want to use one of the methods I show you here to troubleshoot these problems because then parameter sniffing is going to be bad for you. You're going to get stuck with a plan that is not good for all cases, okay? We talked about that. Local variables, please be aware of local variables, okay? Again, I see many cases of developers use local variables because it makes sense. You want to reuse the value of the local variable in your batch again and again. But in terms of performance, this is really a bad thing because the optimizer doesn't know the value at compile time. It generates a plan based on an unknown value, on average statistics, which is bad in many cases. Don't change parameter values inside store procedure or use local variables inside store procedure. Again, if you have to, then either use option recompile to recompile at runtime or send the last value after the calculation to another store procedure to benefit from parameter sniffing there. Okay? And use force parameterization. Prefer the query template level because it might be too risky to do it database-wide. Okay? But use it only when you have to. The best solution will always be to go to the query, to the original query, and rewrite it to use parameters yes or no, depends on the case. All right? Now, back to the story. Remember the story? I went to the client, and I noticed that we had a parameter sniffing issue. Okay? And the issue was the client was right. He didn't do anything. They didn't change anything. The thing is that once in a while, SQL Server automatically updates statistics. And it happens to be that 30 minutes ago, a trigger was, it was triggered, okay, the automatic statistics update. And the next time the store procedure was executed, it had to be recompiled because the plan was invalid. There is a new statistics object, okay? And for the specific execution, the next time it happened, a user used an uncommon value, which caused a different plan that was there before, and suddenly it runs for 15 seconds instead of 2. And it's constant because it's in cache. We get to use again and again and again, okay? So what you have to do, again, we can do many things. What I did in that specific case is to use option optimize for because I understood from the client that there is a specific value that is used 99% of the time, and it prefers to have a consistent, a predictable performance based on that value. But it's risky because it might be correct today. Things change, okay? Maybe in an year from now, it won't be 99% of the cases, and nobody will remember that there is a query option using optimize for in that query, okay? So it's risky, okay? But that's, again, one of the options to use. I want to refer you to a blog I've written recently, a series of posts about everything I talked about here today. Okay, so you can find it on my blog with all the demos and examples and explanations. You can find it there. And are there any questions? On time, more or less, with all the... Any questions? Yes, please.
How the execution can be, if you have a store procedure, but there you do different things. If you have
Several statements, you mean? Okay, so if I have a procedure with multiple statements, the procedure is a batch, and SQL Server compiles the batch as a whole. It will prepare a plan for the whole batch. You can look at the plan and see the plans one after the other per statement. Okay, but you get the whole plan as a whole. The compilation happens for the whole store procedure. Okay? Yes? The previous slide. This one? Oh, okay. Good. Anything else? Yes?
the previous question and answer to why they don't use abstract tree to hash the, they don't in the analyzer, like you hash the command, not the abstract tree that's sent to algebraizer. Wouldn't it be better to, because like you add white spaces but still it's the same query, why not store the transformed version instead of the pure text?
Why SQL Server uses a hash over the text?
Yeah.
And not something else? That's a good question. It's from Microsoft, not from me. I don't know. But, but again, this is not a real situation because you don't use the same query once with a space and once without a space. This is not the issue. The issue is different parameter values, and this will happen in reality. And you want to be able to determine that this is the same query template, okay? And this is what happens when you use parameters, okay? Any other questions? Great. So I have, I think, 2 more slides. One is this one, okay? PASS has a lot of things to offer, and please go and see all those. And the other one is thank you. Thank you very much. I hope that you, when you go back to your workplaces, take a look at your code and store procedures, the way you use parameters, and if there's anything you can improve, go and do it. And if you want to stay in touch, please do. Thank you.